Hello there, Darkness344 here. Today I'm going to be showing you how to program my computer. So, the world download will go out in this map, and yes, guess what? I have worked out on this control panel, so now it should work, at least I think. If I did make it or not, I'm still not sure if I made it. Yeah, it looks about done. I'm not sure if it does work though. We could try. So, yeah, in the last video I showed you this computer, which is pretty big, mind you. And it is a very slow computer, I can say. As you can see from this clock, this is the fastest it can go from what I know. Like, I could probably adjust it a bit more, like adjust this a bit more to make it a bit slower. I mean faster even. Slow. And hopefully it should work better, but yeah, it is a slow computer, as this is my first computer and it is a good computer, but it's slow. So yeah, it may boost impressive specs, but it's quite slow. So first of all, we're going to try this panel. So the way this panel would work was you'd put in a selection, and of course your program would wait for your selection. So say if it was an adding program, you put this number in, and if you didn't like it, you could reset it and put in a different number, right? So here we put 3. Then you can write it to RAM 1 or RAM 2, and that would be your program. So hopefully it's written to RAM 1, and no, it hasn't, so I still haven't got that implemented. And you know what? I think I'll probably leave it up to you guys to get that working if you want to. Like, because this computer, I'm just going to say right now, is probably, if there's no major, but well, there are a few bugs and stuff, I'm going to say this is done. This computer is done, and if I'm going to make a new computer, it's going to be completely different, because yeah, this isn't the most efficient computer, as you can see from like just how it's connected is not the most efficient way, and it's really cool and stuff on like how you have different program slots and how you have a really good ALU and lots of RAM and a nice display. But I think I'll make a better one that will probably only have 2 program slots, because you really don't need this many. Also with a few changes, quite a lot of changes actually to the program, because like look at this, there's 8 lines here. You only need like 4 lines. No, you only need 3 lines for this entire 8 lines, and it's kind of, oh, you know, not the best in the world. But yeah, so that doesn't work, but yeah, you guys can do that if you really want. But so, how to program this? Yeah, that's probably what you're watching this video for. So, this is your core selector or program selector, and the default is 0, so that's all of these off. At the moment I have the Fibonacci sequence loaded on to that program. Then you have your clock on or off to turn your clock on or off. This means each time the clock cycle goes by, it goes from this line to this line, and then it goes from this line to this line the next time, and keeps going like that. Or, well, that's how it should be. But if you say, oh, instead of going to that line, I want it to go to this line, you can say that. And you can also loop it so it goes to this line, back to this line, to this line, 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 and it loops forever until the program breaks. So yeah, that's basically how this type of program counter works. Then you have your reset display, which just reset. I think it resets the entire display. I'm not actually sure. Yeah, it resets the display. I have been working on a new computer, which I will show you in a bit, which does not have a reset display, but instead it just updates the display, which is useful in some ways. And it uses a different display driver. I'll show you why in a minute. So you have reset display, you have your clock cycle counter. This is synchronized when it will go into the program, the clock signal. You have program on, program finished, which just are indicators. You really don't need them. You can reset all the RAM from here, and you can also cycle the clock manually. This only cycles it once, and that is quite a useful feature for when you don't know how long it's going to be. You can just do it manually and check. So programming wise, what you're going to do is you need redstone torches, right? and you pretty much select a core you want. I'd say choose one of the bottom ones. If like this world download will have the Fibonacci sequence loaded onto the first core, and yeah, so you can look how that's coded. I actually have an Excel sheet that I've come up with, and this is so you have all your operations up here. You have your, what's it called, your machine code up here. This is my own take on machine code, and you have some instructions here just to help you out a bit, because it is kind of confusing on how it works. So I'm going back to the game. Also, yeah, there's one big way this works. So first of all, these 4 lines, basically they are not labeled, but they tell you which line to go onto. So line 0 is always the default, and it always starts on line 0. But say you wanted it to go on line 1, what you do, you just put a redstone torch right here on line 1. I should actually label that. So I'm going to go from the bottom and only do it at the bottom. So this would be line 1, at least, yeah, line 1, line 2, line 3, and line 4. Yeah, that bugs me now, but I'm not going to change it. So yeah, it always starts from line 1 here. So say you want it, so it always starts on line 0, and if you want it to go a line, you just address it. This is in binary, by the way. So say I wanted to go to line 4, I just put a redstone torch here, which means go to line 4. So 0, 1, 2, 3, 4. So go on to this line. Yeah, I know it's 5 lines, but it is technically line 4, because this is line 0. Say you wanted to loop it, you say I want to go from line 4 to line 3, but then back to line 4 again. You'd go to line 4, then you'd put line 3 in it, which is 1 1, well 0 0 1 1, and it'll go back to line 3. Then you want from line 3 back to line 4, so it's a loop program, and you can also include operations on it and stuff. Then you say go back to line 4 just by putting 0 1 0 0 on it. So that loops the program. But say if you wanted to end your program, say, oh, I've done the addition, but now I want to stop it instead of looping back to line 0, because line 0 is blank. So if you leave your last line blank, you'll always loop back to line 0. Whatever number your last line is, say it's line 5 you're on, which is this one. Say it's line 5, and that's your ending line. Instead of putting a line 6 or line 0 or whatever on this, you actually put line 5 on again, which means it just stops at line 5. So that's the basics of the program counter. And yeah, this is the clock line, and it goes down. You could probably manually clock it from a button here, but there's not really much point, because you need these D flip-flops are kind of buggy sometimes. Then that's these bits. Then you have your operations for your ALU. You have add, subtract, and, or, not, XOR, shift left, and shift right. I will come to these in a minute, because they work. Actually, no, I'll cover them now. So the way, instead of saying, oh, I want 5 plus 5, instead of putting 5 in, then clicking add, then putting 5 in, you have to do the you have to put the numbers in first. I've forgotten, like old calculators used to do that. I've forgotten what they're called. But yeah, so to put the numbers in, you find the main data line, but data bus or whatever, I don't know, which is this one here, right? The one next to RAM cell ID, not this one, but this one, the one that goes up to 16, I think. Yeah, the one that goes up to 16. So you put your first number in, or you can load from RAM, which I'll show you. Put your first number in, and on the same line, you have to input to ALU A or ALU B. These lines just update the register with whatever's on the main data line, which is this pink line here. So whatever you've put into it, or whatever is going through it, like maybe you loaded from RAM, will be updated onto the register. Then you have program finished and program running. Those just turn on indicators. They're kind of useless. They only help you debug and stuff. Then you have, yeah, and then once you've input your things, so you say 5 on ALU A on line 1, then go to line, on line 0, then on line, then say I want to go to line 1. On line you want to put 3 in ALU B, and then on line, then you say go to line 2, and on line 2 you can say I want to add those numbers, and then you just click add, and then it'll add the numbers, and the data will come back round from this line all the way back into this main data line, and then you can save it to RAM if you want, and that's pretty much it. You can't feed it back in. The only way to feed it back into the ALU is save it to RAM first, then feed it back in. That's how the Fibonacci sequence works right there. Down here, it feeds it back into RAM. Then, to save to RAM, so yeah, those are your operations. On single operations, say you want to not a number, but remember, you're only inputting one number, you always input to ALUA. It's not labelled for some reason. You always input to ALUA, because ALUA, which is this one, this register, is the only input to one operation. So say it's you're notting the number, it'll only input to ALUB. A, not B, as you can see. And that's the same with, so it's for not, shift left and shift right, as you can see. Oh, and yeah, with your shift left and shift right, you have bits lost. They just stop completely, as you can see. And for your, oh yeah, for any add operation or any operation that goes over 5 bits, the carry is just never used, right? Because it's max is 4-bit with one. Don't bother about that second bit. So the carry is never used once a 5-bit. So a 5-bit number plus a 5-bit number, and if it equals a 6-bit number, it will only still be a 5-bit number. That's why the display drive goes weird when you use the Fibonacci sequence, because it isn't super smart, so it doesn't hold on to the last bit and add it in later. So that's the basic operations covered and the data line covered. Then you have saved, and so you have read and write, and your RAM cells. So, oh, and also display, but I'll cover the RAM first. So, say you wanted to write to a RAM cell. What you do, on the same line your data is going in, say I wanted to write 1 into RAM, I'd have 1, and I'd also have save to RAM on the exact same line. Or, say I wanted to get an operation out of the ALU and put it into a RAM, I would have the operation that I want, and already have the numbers in, remember. Say I want to AND it, I'd have and also the save to RAM ID on the exact same line. Then you can specify which RAM cell you want to. There's 7 RAM cells by putting it into one of these. So you could either put it into RAM cell 1, 2, 3, 4, 5, 6, 7 with these binary numbers. And you can do the same with reading it. So to read, you put read and then you specify the RAM cell you want. And then you can read it and like put it into ALU if you want. Then if you wanted to put it into, you want to read a RAM cell and put it to ALUA, you just do read RAM cell 1 or whatever number is, and also on the exact same line input to ALU A or B, whatever. Say you wanted to display the number, the only way to display the number so far is actually the output from the RAM. So say you wanted to display the number 5, first of all you would have to save it to the RAM, which is kind of annoying, but it's just a buggy feature of this. So you'd save the number 5 to RAM, and then you'd read the RAM, so save the number 5 to RAM on this line, and on the next line you'd say I want to read the RAM number 5, and you'd also put the display on it, and this display line basically updates the display register. So if you come over here, if we come over here, it basically goes through here, and this register, the display line pretty much just updates this register. So any data that goes through gets updated right here and sent into binary coded decimal to binary to binary coded decimal converter and into the binary coded decimal display, which this one's my design and that's also my design. Most of this is my design here. The D flip-flops are not though. They're a very, very old design, I think, from like 8 years ago, 10 years ago, who knows. But yeah, that's pretty much the basics of programming the CPU. There are a few things that are still buggy and stuff. And remember, you can slow your clock down and stuff with this. Let me check my Excel just in case. So lines means jump to specific line. One command is executed per clock cycle. So one line is executed per clock cycle. As you can see, this Fibonacci sequence, it totals of 6 lines, but so from 0, 1, 2, 3, 4, 5, 6. As you can see, then you have add, subtract, and you have your operations. They'll give out, when activated, they will give out the answer to the main data bus, which is the pink wire, on the exact same cycle. Then you have your main data bus, you can input to RAM and ALU. Oh yeah, that's one thing. When you read a RAM, it will also come back out here. So say I read number RAM 1 and the data was 5, it would travel all the way down here, all the way along this pink line, into the display, but it won't display unless you click update, and back right in to the main data bus. So you could read directly from RAM and input it to an ALU, a register on the exact same line, which is quite useful. But that should be a feature anyway. Then you can write to RAM cell, read RAM cell, specific RAM cell. Yeah, the RAM cells on the same line of code, display updates. The display register to current number. No, you have to be reading from RAM to display a number. Yeah, remember that. You can't just typo. You know what, I'm really not going to change that. Another typo? Way. Running turns on the indicator lamp. Finish turns on the indicator lamp to show the program and stuff. ALU, A and B. Yeah, ALU A only. Remember that. And then I'm gonna give this exact Excel sheet so you can put in your. So this is the Fibonacci sequence. You can edit it maybe to make it a bit smaller. I'm not sure you can make it smaller with this computer, but it's pretty cool. It's pretty small and it works fairly fast. Well, on this computer, not super fast. It like takes, I don't know how long it takes. It takes this length of the clock, so 1, 2, 3, 4, you know what, I'm not going to count them. It takes a long time, but it works in the end. So now, that's the program of it. So now you can also add stuff to this computer if you really feel like it. Make sure to feature me, like give links and credit to my channel, because this did take a very long time and it would be nice to have a bit of credit and not people just steal my stuff, because that's not nice. But yeah, give credit to me if you use this design, or if you edit this or do videos of this, or upload it to anything. Actually, yeah, don't upload it without my permission, so ask me in the comment section if you want to upload this. But yeah, it's pretty cool, and I will leave the world downloaded in the description, so I hope you like this. There will be no instructions in this, so remember to watch this video, which you probably are doing. So yeah, now I will show you my epic new computer that I have been working on. Yay, I have 2 friends, oh my god. Me and myself. AX344 version 2. You saw TNT practice, that's because I'm trying to blow up my friends. Alright, so, on to the new calculator. Computer, it is this big. It's a 4-bit computer with only 2 ALU functions, add and subtract. I will be doing tutorials on this if I can be bothered. Only has 1 program counter line thing, but it is rapidly fast. This is the clock. Look how big it is compared to the other one. Well, the other one was like 5,000 repeaters. Look how big it is. Yeah, the display panel's rubbish, but look, I've programmed Fibonacci sequence on it, and look how fast it is. This is almost max clock speed. Well, it is max clock speed without overclocking it. So it should go blank first, then it should go 0 again, and then it should go 1. As you can see, that's the clock. 7. Yeah, I think I forgot to reset the RAM. Whoops. So reset the program, reset the RAM, and update display. Should update to 1, I think, because I wrote it on directly on line 1. If you don't want that to happen, you could. I'm planning. Yeah, in my video, I'll add a line like this, like right here, that turns it on or off. So there'll be an on-off switch. Yay! Everyone wants an on-off switch on their computer, just to turn it on. Whoops! But it should go 0, 1, 1. If it goes 1, 1, 9. That's not right. I think the clock's broken. I think I'm doing it too fast. It was working earlier. I can guarantee it was working earlier. But this is stupidly fast. Basically, when it does work, if it works. I don't know why it's not working. There's probably something in the RAM that's wrong. I don't know. Yeah, but it's a much smaller computer, as you can see, and it runs very, very fast, even though I can't give a working program demonstration. But I may do a tutorial of this. I built this with the intention of doing a tutorial. As you can see, it uses a different display drive. I'll cover that in the tutorial if I make one. But yeah, this is a very fast computer that you can program with pretty much the same instruction set. So I will cover that in the tutorial when I make it. If I make it, hopefully I'll make it. So yeah, please like and subscribe, and hopefully I'll make a tutorial of this because it's pretty fast and pretty cool. I keep saying the word fast. Alright, never mind. Please like and subscribe, and I am out. Hope you enjoyed this video. Thank you for watching. Yeah, see ya.